All right, so we'll just quickly start from where we stop. So do you remember where we stopped last time? Do you still remember where we stopped?
Yes,
I think what we did majorly
yes.
in that class was basically introduction to what data science is all about, right? That was
Mhm.
our major focus. Then, so what can you say about data science briefly before we continue? So what is data science? Quickly, just to know if you still have the memory.
Data science. Data science uses machine learning algorithm
Is the what?
in training. It uses data science algorithm to train the computer to learn and make decisions.
Sorry, I didn't get you say using the what? The computer.
Ma- Data science uses machine learning algorithm to train the computer on making decisions.
Okay. Making decision on data, right?
Mhm.
Okay, so if you remember, I think we covered this particular diagram that I'm having on the screen. Hope you have seen the diagram. Let me see if I can remove this stuff.
Yes, we did.
Okay, now this is to establish the branches of machine learning. And if you look at the diagram, the whole thing you are expected to learn as data scientist or in data science is divided into two broader categories, such as supervised learning and what? Unsupervised learning. Though we have discussed most of these things, but I just want us to consider more of some of the foundation before we go to Python Jupyter Notebook. And meanwhile, make sure you are getting ready your Jupyter Notebook while this session is going on. So just to summarize, introduction to unsupervised learning as one of the branch of data science. Now, unsupervised learning is about finding insights and patterns hidden in the data. Unlike regression or classification, we do not care about splitting our data into train and test sets and making prediction. We just care about understanding the relationship in our data. Now, what we are simply saying here is the field of machine learning, which is comprises of supervised learning and unsupervised learning. One of them deals with training data set for prediction, while the other one focuses more on measuring the relationship, grouping data into that is data that are related. Now, all of them works together. All of them work together. That is the reason why, as a data science student, you need to understand the unsupervised learning, and then before you can fully go into the supervised learning, because the unsupervised learning focuses on structuring the data. And when the data is properly structured, then you can now begin to train such data for prediction. Now, the diagram have already mentioned it. If you look at under supervised learning, we have, that one has what we call labels, while under unsupervised learning does not have a label. And then if you look at the way I further broke it down under that unsupervised learning, which we are focusing on first, is that it's used to describe or organize data in some non-obvious way. So the focus of it, as it has been summarized here, is that it deals with finding insights and what? Patterns from data. That is the focus of unsupervised learning, which is the focus of the first part of our training. Now here, I further break it down. You can see clustering customer base on listening behavior. Here I'm using a simple data set, which we have. Maybe later I will send you the sample of the data we are going to use for today's training. Now, this is just to give you a picture of what we are talking about. If you look at this data, we have three columns. We have the column with customer, we have the column with music streaming hours, we have podcast listening hours. Now, since unsupervised focuses on segmenting, that is, we want to group, we want to find out the relationship between this customer and the music they stream and the number of hours they spend in streaming each of this music. Are you following?
Yes, sir.
Good. Now, you can see that the data is not grouped. This is it at raw state. So the simple question we should be asking ourselves here is that how many, that is, how can we segment these customers? How do we know the ones that, how do we measure the relationship between the streaming hours and the podcast listening hour? That is what our focus is. So when you are given this kind of data, this is, you are to apply unsupervised techniques for you to be able to what, to segment this customer into a music streaming hour and podcast listening hour. Now, this is where we have applied unsupervised concept to have been able to identify or to segment them. Now, these are features, these are features, what goes into the model. Now, there are certain terms we need to understand. The word feature here is used to describe what we know as columns or attributes. For example, now customer is a feature. Music streaming hour is a feature. Podcast listening hour is another feature. Now, if you look at by my left-hand side, each row represents a customer. If you look at the data, that is how it is structured. Each row represents a customer. And if you look at my right-hand side, there is a note that there is no target here. There is no target here, unlike the supervised method where you target a particular column for the prediction. Here, you are not targeting, you are only focusing on segmenting. Now, you have already segmented using, this is achieved by using unsupervised techniques or models. So you can see that the cluster one, that's what the first set, we are able to group them. These are music lovers. These are music lovers. Then the cluster two, these are podcast enthusiasts. Then cluster three, these are casual listener. So which means that these people does not really spend time. That's the cluster three, does not really spend time to to listen to the music or to stream. So if you check the value corresponding to each of these people, you will understand what we are saying. Now, take for example, Aria. Aria has 46 music stream hours. And then the podcast listening is 9. Then chord has 38. The harmony has 44. And then if you look at the next set of people who has more interest in podcasting listening, you see that we have 19 there, and then we have 7, then we have 16, and then you see how it kept coming down. So with this, we have been able to apply unsupervised method or techniques to be able to segment. So what I'm doing here is just to give you a picture of the focus of this aspect of machine learning. The focus of it is not prediction. It's not about training data or testing data for prediction. The focus is just when you are given a data, how do you group certain behavior into different segments? Now, the next section here, what you had there is what we have been able to visualize. Of course, you know that in data science or analysis, we don't joke with visualization, because visualization helps us to identify the pattern and the trend easier. Now, what we are having here is just like a scatter plot. So we are trying to also represent the whole of those segments I just show you now with this graph. So these are the customers in our data, these 3 groups. So we have been able to group them or segmented them into 3 aspects. So if you look at the left-hand side, where we have the legend that explain each of these graph entity. We have the other color, which is the orange for music lovers. We have the podcast. We have something like blue there or purple. And then we have this light, can I call this, can we call this something like, okay, so that color actually represents casual listener. So with this, you can see that we have more music lovers, followed by the podcast enthusiast, and then we have the casual, just like the way we have it in the first relation that I just showed you. So I just want to go through this so you have some foundation on unsupervised learning before we move to the application. Now, here we are looking at unsupervised learning techniques. Each of these aspects of machine learning, like I started by telling you, has different techniques that are deployed for you to actually implement them. When we get to supervised, we will be deploying different methods for us to be able to come up with a reasonable prediction. Now, in structuring data or determining the relationship between them or grouping them, there are techniques that are involved. So there are 2 popular categories of unsupervised learning techniques. When they say 2 popular, which means that these are not the only techniques, but these ones are more popular compared to the other. And what are these techniques? We have clustering and we have dimensionality reduction. So the clustering is talking about grouping them, segmenting, just like we just saw in that table and that graph. Now, dimensionality reduction is talking about where you have too many headers, and then you apply a method to reduce the number of header in order to help you achieve your goal. Now, if you look at the explanation under each of them, under clustering, what you'll be doing as a data scientist is identifying groups or clusters of data points that are similar to one another, but distinct from other groups. A typical example is this that we have just explained. So at this point here, you were able to identify these people and group them as cluster one. You were able to identify this set of people and group them as cluster two. The same thing applicable to this. And that is what I am explaining here now. Now, common techniques under the clustering techniques is that we have the k-means clustering, we have the hierarchical clustering, then we have the DB scan, which means the density-based clustering. All this, we are going to see their practical application. So what I'm trying to do here is to give you the foundation of all this so that when we start handling data in Python, you'll be making reference to all this. So under the application, clustering, segmentation, anomaly detection, then recommenders. Now, if you look at this dimensionality reduction, what you'll be doing is reducing the number of columns, which I've mentioned before. You can be given a data set, and then you discover that the main features that will actually help you to be able to segment the data into group based on their relationship, they are not, or maybe they are not well arranged. In some cases, it might be that the data set is just overpopulated with headers that does not in any way assist you in achieving your aim. So what do? You remove them. So there are techniques, there are functions that can be used to drop column that will help you in reducing the data frame width or the features. Remember, anytime I use the word feature, is the same thing as the headers or the attribute. So that is what you'll be removing. The dimension here, talking about the length of the data. And when you say dimensionality reduction, it means that you are reducing the features. You are reducing the length of the data. And the essence of doing that is for you to be able to group them easily. So the common techniques that are applied here are PCA. All these special terms, you need to know them, because as we continue in some cases, we will just be using them. So I expected that from this slide, you must have known their full meaning. PCA means principal component analysis. So here you are going to be able to identify the principal. We're talking about dimensionality reduction. You need to identify which ones are the key. Then we're going to talk about TS name, which it means that the T stochastic neighbor embedding. All these, you will see them. Just like you are using a kind of relationship. When we use the word neighbor, just like your normal resident, where you have, let's say if you have people in a compound and then you want to group them, because this is about segmenting of data. So you can group people based on how they are close to each other. That is what that TSNE is talking about, using that concept. And then we have singular value decomposition. That is those ones that are also related to themselves. So all these are techniques that we use in segmenting data. Then feature application, just like the way we have it here. Here we are going to look at features extraction. Remember, feature means heading. So there are times you will extract feature, data visualization, and then recommender. So at some point, even when you are doing this, you can also introduce new features just to enable you achieve your aim. Now, we are still on unsupervised learning application. Let's look at some application, which I have already mentioned, so I will just run through them briefly. We have anomaly detection, which deals with identifying rare points in a data set that deviates significantly from the rest. That is what we mean by the anomaly detection. Identifying data, identifying some points, some rare points in your data set or some value that are totally different from others. So when you apply this method, you'll be able to work to separate them and group them. Then here is still under the same clustering techniques, isolation forest. This one, you are going to be taking them off. Once you detect such, you remove them. And that is still the segmentation we are talking about. Then other techniques, like I said, there are many techniques, but we are focusing on the most used or the most common method. So statistical analysis, time series analysis. Then under recommenders, what you'll be doing is suggesting items to users based on their preference or behavior. So once, just like that music, that data that I just showed you, after your segmentation, you'll be able to recommend, based on what? Their preference, their behavior. You'll be able to recommend, because that is one thing this unsupervised helps us to achieve. So once you group them, you will now be able to know, you will now be able to get the insight from them, able to know which one is doing better, like we just did now, that we notice that we have more of music lovers. So then you can use that idea to what? To recommend based on your clustering. So clustering techniques, dimensionality reduction techniques. The structure of, so what we are doing here, this is the whole of the course, how it's structured, category or supervised learning. These are theoretical aspects of it. So I don't want to spend time so that we can get to the practical aspect. Now we have the workflow. The workflow, this is very important, this aspect. Remember in the last section, I explained all these application number 1 to 6, where I said they are not serially considered. At some point, you can be at 1 and then go to 3 and then come back to 2 and so on. Now, we are just pulling out this very one, which is very important to unsupervised learning, modeling data. Because the whole process of you grouping data, what you are doing actually, you are remodeling, structuring data. That is another word for that modeling. You are creating different models for you to be able to identify pattern or insight. Now, under this, there are 4 aspects we need to look at. We have the data preparation, which falls under data cleaning that you know in data analysis. So there are some points for you to be able to segment data under unsupervised learning. You first of all, clean off the data. So there are a lot of cleaning process under this unsupervised, because before you can be able to effectively group or segment your data for better insight and pattern identification, then at some point you have to do a lot of cleaning. So after cleaning, you define the algorithm. The algorithm, like I told you in the last class, is just like the model. And then I told you that we have flow charts. So let me summarize the algorithm here as like the steps that you will use to achieve your target. Then we have tuning. You have to tune the data. You have to and make it look more healthy. Then finally you select. And then with that, you have been able to successfully model your data. So if you look at the brief notes that I have pointed out under each of them will give you a better understanding of what each of them does. Like under data, I said what? Get your data ready to be impute into a model. You have to get your data ready. The single table none, you have to make sure that there is no missing value. That is the summary of that first option that says single table null, not null, and then numeric data. You need to also ensure that the values that are in your respective column, they are numeric data. So that is emphasizing of you not having missing value. Then feature engineering. So at some point under data preparation, you re-engineer some feature. That is what you bring in new headings in order to achieve your target. Then selection and scaling. So there are times you need to what? You pick the most prioritized column in order to have your segmentation ready. Now under algorithm, you see apply an unsupervised learning techniques. That is algorithm. That is how you are going to deploy it. Clustering, and the algorithm we are going to use is clustering, dimensionality reduction, which I have already explained before. Then tuning, you'll be evaluating and tune the model. So after the whole of this exercise, at some point you sit down and reevaluate the entire model to see whether it actually fits the need or not. So using metric and what? Intuition. So here, look at metrics, that is inertia. Now we look at data visualization, then you interpret the result. Then selection, pick the best result and identify any insight. So business objective, domain expertise. So all these are different stages that you should expect in the process of, or as the workflow of unsupervised learning. I just want to see. So I've talked about this before: cleaning data, exploring data, modeling data, and their respective meaning, just like we have explained before. Now, the key takeaway here, I want to see how we can get to the practical aspect. The key takeaway here is that unsupervised learning is used to find patterns and relationships in data. There are no prediction or label with unsupervised learning. We are just trying to better understand the data, non-obvious structure, organization, and relationship between data points. Unsupervised learning has a different mindset than supervised learning. Unlike supervised learning, unsupervised learning does not require splitting the data into training and test sets, and evaluation is based on heavy dose of domain expertise in addition to metrics. There are multiple applications for unsupervised learning techniques, while the two main categories of unsupervised learning techniques falls under clustering and dimensionality reduction. The techniques can be used at multiple steps of data science workflow, so blah, blah, blah. Now, this is where we are actually going to zero our practical in, which is the first particular stage under the technique where I mentioned pre-modeling data preparation. So this is here, what we are ready to cover here is modeling data preparation. In this section, we will review the data prep steps required before applying unsupervised learning algorithm, including making sure the rows, look at the emphasis here, making sure the rows and the columns are set up properly. That is the primary objective. For you to be able to segment your data, you need to make sure that what your row and columns are properly arranged. So here we look at, so you see all these are what we are going to focus on as far the unsupervised techniques is concerned. We're going to start with data preparation steps, look at row granularity, and then we'll look at column preparation, feature engineering. This is where we'll be creating different columns just to be able to have our target achieved. Then feature selection, feature scaling, all these I've summarized them. So what is the goal for this section? The goal for this section is learn Python techniques to adjust row granularity and make sure all values are non-null and numeric. That is missing value. So there are different techniques in Python we are going to use to make sure that we achieve this target. Then our next goal will be applying features engineering techniques for unsupervised learning models. So here we are going to also apply some techniques that deals with engineering features like headings or attributes. Then understand why identifier columns should be excluded from modeling. Now, what this is talking about, you can be given a data set where you have value repeated. You have rows repeated. They are what we call identifier, unique. So once we discover that they are unique, then we use Python techniques using unsupervised model to remove them. Just like we have two things that have similar identity. So why compounding the data set? You can actually collapse them to one row. So in data set ordinarily that have about 600 rows, you can re-engineer, you can remodel it using this unsupervised technique to reduce it. That is why we mentioned dimensionality reduction. All these are techniques. Then identify situation where feature scaling is needed. So this is the goal of this aspect. Now, pre-modeling data preparation. These are common data prep steps required to transform your source data into a format that can be directly input into an unsupervised learning. So you can see this entire journey. We will start from data preparation step. We will go to row granularity. We'll look at column preparation. We'll look at feature engineering. We'll look at feature selection. We'll look at feature scaling. So all these are steps we are going through. But today, our focus is going to be on this. So I have listed them here. We have setting the correct row granularity is going to be our first test. Then ensuring each column is null and numeric. That is where we ensure that we don't have missing value. Engineering features for modeling. So at some point, we will create from the data set, we will create another columns just for us to achieve our target. Then at some point, we'll also look at selecting features and excluding identifier columns that look the same. We will eliminate them. Scaling features for distance-based unsupervised learning algorithm. So we'll also be looking at the most important one. Now, you can see, look at this data we are now under row granularity now. If you look at this data sets carefully, to set the correct row granularity, think about the question you are trying to answer and determine what one row observation of your table will look like. Now look at this simple data. Initially, you have how many rows here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have remodeled it after removing some rows that have the same identifier. Look at what you have. You have reduced, this is a dimensionality reduction that I talk about. You reduce the dimension of this data to this, which is better presentable. Here, look at it. You have 3 columns, and here you have 1, 2, 3, 4, 5. So you converted some row to column by grouping them. Here now we have area 50, and you have that area here repeated. Look at this here, area 50, area 48, area 1. Now, you converted these 2 columns, you created a different column. Everything about area is what you have in one row now. So this is a typical example of the dimensionality reduction that we have been talking about. You can see that this data is well structured. So to achieve this simple structure you are seeing in Python, you're going to write code. You're going to write unsupervised code for you to be able to achieve this. So like the note I have here, this table has the correct data, but it needs to be reshaped so that each row represents one customer. That is what we did here now. Each row represents one customer. Here, you can see that you are having 3 different rows representing one customer. So why don't I just collapse? Now, even as you are collapsing, understanding that we have the gen here. So what will happen is that even as you are collapsing the customer value under each of this category. So area under pop, you see it 50. Area under India, you have what? This. Area under rock, you have this. So you have simplified. So it's not as if you actually throw away some value. You just restructure it. I want to know if you are following.
Yes, sir.
All right, so now this is Python code. So I just wanted to show you what we are going to do. Then we will now go to Python and practicalize this. Now, if you look at the first task I'm performing here, which is under row granularity, that row granularity is talking about what we just did here now, reducing the number of rows. And what algorithm did we use, or what techniques did we use? The technique we use here is identifier. We identify that this row area, they have repeated value. So we just leverage on that to reduce the number of rows. Now, this is a data set. Like I said, I will send you the data sets. I have all the data sets that we are going to be using for each of these training. So now we are working with this data set. Now, if you look at this data set, here we have about 9 rows. And at the end of the day, we reduce them to what? 4 rows. Using that same concept. Now, there's a function that we are focusing on here, common way to reshape data to the correct row granularity using group by. So the first function we are going to use is using group by to combine all rows or records with the same ID column into a single row. Now look at the simple Python code. Of course, from your basic knowledge of data analytics with Python, you know this is comment, right? Do you still remember that? Good, this is a comment. Now, this is using a group by, and because I am separating them, I can also write this on a straight line. So I write all of them in a parenthesis just for me to have the code arranged in this format. So DF is your data set name. Then you concatenated it with the group by function. Then you specify your condition. Your condition is that the summary of this data now, for you to summarize this to this smaller version, is that you use a criteria to group them, and the criteria is the customer names. And then you now select, you are grouping them by the type of songs they listen to. Are you with me?
Yes.
By the type of song they listen to, which is this. Now, this reset index is what brings this, that is what it should start the numbering. By the time it picked them, it's possible that alphabetically, area may not be the first one based on the value arrangement. So this reset underscore index is to calibrate this number, this serial number. That is what, if you remove this now, you will not have this. If you stop at this. Now, what it did is that you concatenated a summation function which falls under aggregate function. You use this function based on this selection to summarize the value. That means that what all the values attributed to area, if you add them up here now, this is what? 50, right? For area, which you have selected here, plus what? 48, plus what? 1. That is what gives us what? 99. Then if you pick all the chord value here, you will see that what? They will give you this. So that is the techniques I use to reduce this. Now, let's quickly go to Python now and demonstrate this. We'll come back to this later. But do you have any question? Okay. Now, to set up your environment in Python, remember that you open your Anaconda, and then launch your Jupyter notebook. Is you can be opening your own, or maybe you just watch the step first, then I'll give you time to practicalize everything I've done so far. Just make sure you pay attention. I hope you are recording from your end. Success, are you recording? Hello, can you hear me?
I think so.
Okay. Okay, that means I'll have to send you the... I hope you are taking note. You have to start taking note as we proceed now, because we are entering the practical aspect now. All this grammar, we are blowing since we want to see how we can put them into action. All right. I hope you are still seeing my screen. Okay, so the first thing we are going to do here is for us to create our project folder inside the Jupyter Notebook directory. So that's the first thing I'm going to do here. So before I proceed, I have to go to desktop and create a folder. I'll go to desktop and create a folder. Then from here, I can just give the folder name. Let's say what? Prep, or let's say data underscore prep. Now, inside this folder, I have some of the data sets I'm using, which I'll send to you. All the data sets we want to use for this training, they are here. So what I will simply do is to transfer a copy of it inside that folder. Make sure you are following the step. So I'll open this, my folder on desktop, and then paste it inside. Now, the next thing I'm going to do is for me to go back to my Jupyter notebook. My Jupyter notebook. So from here, I will switch back to desktop in order to access that folder that I created where I have all my resources. By double clicking, you will notice that it will appear, your URL will change to this. You know, initially, this is where we were before. So now I will just double click here and then to show me, to redirect me to desktop. Now we're on desktop. So once you get to desktop, you can then see the name of that folder that you created. Now, you make sure that you are on that folder like this. Hope you are with me.
Yes.
Good. So once you are inside that folder, it is inside this folder that you now create your notebook before you go to new and select Python 3. Now, you see that you have created the file. So the next thing I'm going to do is to open this file to see my notebook by double clicking. So just like what we are familiar with. So you can see it's opening the... Okay. Now, I believe you understand how we got to this place now, right? Okay. Now, the next thing I'm going to do is to title my notebook by clicking here and then specify the name. This is data. Let me just make it prayer.
Yes.
Let me just try to be different from my folder name. Now, the next thing I'm going to do here is to... The next thing I'm going to do here is to create a comment, which I believe you already know. So Shift and 3. And what are we doing here is data preparation techniques, data prep. Now, I want to convert this comment to a kind of notes. We call that markdown. So I want to mark down this. And to simply achieve this, you click on this here, and then you come to beside the code, you select markdown. And then once you have done that, while you are still selecting, just press Shift and Enter. Just press Shift and Enter. I think it's loading. Hold on. Just select it and press Comment. Good. Shift and Enter. It was loading the other time. So you see, I have converted it to what? A note. It's no longer in a live cell. Did you understand what I just did now?
Yes, it again.
Okay. So let's say I want to write a statement that this is a comment. Let's say I want to say, we are learning how to reshape data sets in Python using group by function. Now, this is a comment. I don't want it to be in a cell, in a row. I want it to be like a note, like an MS Word. So what I did is you select this first, and then you come here and switch from code to what? Markdown. Then after that, you now press Shift and Enter. You see that it has converted it to what? Ordinary write-up. It's no longer the way it was in a cell. So for example, now your insights, maybe your explanation, at some point you can convert them to a note like this instead of running them in your cell. Did you understand that?
Yes, sir.
Now, I want to create a comment. The first thing we want to do here is what? Reading the DF data using Python dictionary. So this data that I want to create now is not as if it has been created, but we are using dictionary. That's why I say you should go and learn dictionary. Now, all this has been created to avoid wasting our time. So I will just come here, go to this, and then I will just go to this. This is where we are now, section O, data prep code. So just click here, it will open it with your Visual Studio Code, then we'll just copy it and paste it there. And that will give you dictionary code structure. So I'm waiting for it to open in my Visual Studio Code so that we can lift the code to save our time. Okay, so you can see, create a sample data frame. Hope you are seeing my screen. So this is dictionary. If you have actually practiced that dictionary, you will notice that this was the structure. You know, a dictionary has key and value. Now this is, here you import pandas as PD because you need this library for you to be able to what? To read data. So let me just take the whole of this, then copy it, then go to my notebook. Let me just paste it here. Then you can see it here. Then all you need is just to run it. Then the data is created. So this is the data that I was showing you in the slide. Is it clear to you?
Yes, sir.
So what you did here, you already know this is a library, right? Now, this songs underscore dictionary, the name of the file, this is the dictionary that generated the key and the value. Then you took the whole of it and store it in what? You use this function data frame to capture this data set and store it with the help of pandas in your DF. So DF is your data set name. And then what you did here, you just call what? The data set name in order to see the value. So now we can now go back to the slide now and see how we can use the group by, because under the reshaping data, which is an element under row granularity, I said the common ways to reshape data to the correct row granularity are using group by to combine all records with the same ID column into a single row. Then we also have another one which is called using pivots, but this morning we are focusing on using group by first. Now let me just take us back to that slide so that you know where we are coming from. So this is what I want to implement now. This is what I want to implement. Now, but implementing this, here, the first thing I want to do, let me use Just give me a minute. So like I said, we are using the group by. So if we are using the group by to implement that very slide, which is this. Just a minute. Come. So the task here is I want to know for each customer, how many songs they listen to. That's my target here. And how to aggregate them. So this is actually the task. I want to know how many. I want to know for each customer how many songs they listen to and how to group them. So that is our target here. So like I did the other time, I want to make this a comment. So I'll mark it down and then use the same shift to convert it to notes at this point. Now to run the live code, remember we have the df dot group by. We have the df dot group by. Then select the customer. Remember we are using customer. So at time to avoid making mistake, you can copy from here. So that will be sure that you are using the same case. Then you close this bracket. Then you select then there's a criteria that you are going to use to summarize the customer, which is, I'll go back to this, but let me take it from here also for me to be sure I'm working with the right feature. Now, like I said in my slide, you can decide to have everything in one row. So if I run this code like this now, remember that the one of index is not there. Now look at the way it presented it. So I purposely ran it this way so that you know the impact of that index. So if you don't add the index, you can see that you don't have number one like this. Are you following?
Yes.
Good. So that is why the moment I come here and I add dots, or let me still have this. Let me copy this. Sorry. There's no. Okay, the moment I add the index, once I say dot reset underscore index, once you add it, you will notice changes. If I run it again, you see that I have a better what? Presentation. So that was what I was actually explaining. The role of this what? Reset underscore index.
Index.
So if you don't add it, your data will not be properly what? Structured. In fact, if you look at the way we have it before, we were not seeing this particular label. We were just seeing this. We're just seeing the value. We're not seeing this at sum. So this is a proper structure. Any question?
Yes, sir.
So I want to send you this data now. Let me see if I can quickly send you this data. So that you can perform what we have done so far. Let me see whether I have it here. Okay. Let me also give you this code. So you can see that that file that we're working with is here. So even if you take it to another system, you can open the notebook. Okay, so I will send you the data now. Then you share your screen and perform exactly what I've done with that group by before we proceed. Any question?
Sure.
Let me try and send you the